DuckDB under the hood. Reading plans is the single most important skill in this course. Every module from here uses them. Every optimization we are going to study is visible in one of these trees. Today we learned to read them. DuckDB under the hood, module 02, reading query plans. A query plan is a tree. It's drawn upside down. The root is at the top, the leaves at the bottom, rows flow upward. That's the whole reading rule. Start at the bottom, work up. The leaves are where data comes in, usually a sequential scan on a table. Each node above takes rows from below, does something to them, and passes them up. The topmost node's output is the query result. So if you see a plan with sequential scan at the bottom, then filter, then hash group by, then projection at the top, that's scan the table, filter rows, group them, project the columns I asked for, in that order. You don't need to memorize every operator DuckDB has. There are dozens. You need to recognize 8 of them. Few today, the rest over the next 3 modules. Sequential scan reads rows from a table. If there's a filter DuckDB can push down, it lives inside the scan. You saw that in module 01. Projection keeps only the columns you asked for or computes a new column, like revenue times 1.1. Cheap filter drops rows that don't match a predicate, sometimes a separate node, often pushed into a sequential scan. Then the 2 heavier ones that appear in almost every real query. Hash group by builds a hash table keyed by your group by columns, accumulates aggregates into it. We'll spend an entire module on this later. Hash join takes 2 inputs, a build side and a probe side, builds a hash table from one, probes it with the other. The right-hand side of the tree is usually the build side, remember that. 3 more you'll see later, order by, top n, union. We'll name them when they show up. Here is plan 1. I will run explain on the wide table sum. Bottom, the sequential scan on wide. Revenue is the only column it passes up. The other 9 are never read. The projection strips each row down to just the revenue value. 5 million values flowing upward. At the top, the ungrouped aggregate, your sum. 5 million values in, 1 result out. That is the simplest plan DuckDB draws. Now the group by plan, I will run explain on the sales query. Bottom, sequential scan on sales, projecting region and revenue. 2 columns up the tree this time. Above it, perfect hash group by 10 possible region values. DuckDB builds a compact hash table with 10 buckets and accumulates a running sum per bucket. The projection at the top passes the 2 output columns through. That is the whole plan. How do we prove the hash group by is where the time goes? With explain analyze. Explain shows you the plan, the shape of what will happen. Explain analyze actually runs the query, then shows you the plan plus real numbers. How many rows flowed through each operator, how long each one took. Explain is free, it just plans. Explain analyze pays the full query cost because it actually executes. Use explain when you want to check a plan's shape without waiting. Use explain analyze when you want to know where time is actually going. Now run explain analyze on the same group by, same tree, but now every node has timing. Bottom, the table scan, 1 million rows in a few milliseconds. It reads and moves on. The hash group by is the heavy node, 10 rows out, 10 milliseconds, that is where the CPU time went. That is the point of explain analyze. Find the node that dominates. The rest of this course answers why it dominates and what you can do about it. Last example, the one where the tree finally branches. Create the regions table, 10 rows, 1 per region. Now run explain on the join query. 2 sequential scans at the bottom, 1 per table, sales on the left with 1 million rows, regions on the right with 10. Both scans feed the hash join. DuckDB builds a hash table from the smaller side, regions, then probes it with every row from sales. The smaller table is always the build side. Above the join, hash group by groups, by region name. Because region name is a string with more than 10 distinct values after the join, DuckDB picks the general hash operator here. The projection selects region name and sum. Scan 2 tables, join, group, project, read the tree bottom to top, and the SQL writes itself. One last thing to know, every operator carries 2 row count numbers, what DuckDB estimated before the query ran, and what it actually observed after. Why does it matter? When they disagree badly, say the plan estimates 1,000 rows and you observe 10 million, the optimizer made a choice based on wrong information. A bad estimate can cascade into a terrible plan. We're not going to debug that today. I just want you to know what the 2 numbers mean when you see them. You'll see them in every explain analyze from here on. Quick aside, there's a browser-based plan visualizer built by Professor Grust's team at the University of Tübingen. Paste any plan output, get a clean rendered tree. I'll leave the link in the description. I'll mostly stay in the terminal in this course, but that tool is there if you want it. Your turn. Pause the video. I'm going to give you a query. I want you to sketch the plan on paper before you run it. Bottom to top. Name every operator, then run, explain, and compare. The query is on screen. A single table group, by with a filter, an order by, and a limit, 3. Sketch the plan first. Bottom to top. Name every operator. Then run, explain, and compare. Welcome back. Here's the solution plan. I will run explain on the exercise query now. Bottom. Sequential scan on sales. Notice the filter, revenue greater than 50, is inside the scan node, not above it. DuckDB never produces a row it will discard. About 200,000 rows pass through. Perfect hash group by aggregates the filtered rows into 10 region buckets. Same operator as before, but with roughly half the input because of the push down filter. The limit 3 with order by becomes a top n operator, not a full sort. DuckDB keeps only the 3 largest running sums as it scans. No global sort of the full grouped result needed. The projection at the top selects region and sum. 4 nodes all expected, except the filter landed inside the scan. 3 things to take away. 1. Plans are trees. Read bottom to top. 2. Explain shows shape. Explain analyze shows shape and timing. Use analyze when you want to know where time goes. 3. The operator you care about most is the one eating the time. The rest of the course is about understanding what those operators do underneath and why some are slower than others. Next up, Module 03, columnar storage and row groups. We open up the sequential scan and see what's actually under it.